So guys, welcome sa subject natin again today for review mechanics. We will be continuing our discussion with regards to kinematics. No? So for part 1, we have already discussed yung rectilinear translation. So for this session, we will be focusing our discussion in solving problems involving curvilinear translation. Okay? So as part of the learning outcomes, still state and illustrate yung kinematics natin, yung um, moving motion na tayo, no? To solve problems involving theory of kinematics. So topics to cover for this session are as follows. So again, curvilinear translation tayo and we will be discussing um, three parts or three different applications of curvilinear translation. We have yung rectangular components, we have projectile motion, and we have normal and tangential component of the acceleration. Okay. So curvilinear motion is defined as a motion that occurs when a particle travels along a curved path, no? So ang difference na dun sa discussion natin ng part 1 is yung path nga. So along straight line tayo sa rectilinear, ngayon curvilinear tayo. So ibig sabihin curved path tayo. Okay? So it can be in 2 dimensions or in 3 dimensions. So later we will be discussing those. And then this type of motion is more complex than rectilinear motion. More complex in a way na kino-consider natin nga yung tinatawag natin components of our forces, no? So, sabihin yung velocity natin, may component siya, yung acceleration natin, may component, as well as yung ating position. Okay? Pero, yan. So, didiscuss nga natin again yung tatlo. We have yung rectangular components, motion of a projectile, and normal and tangential components. So, let's start with rectangular components. So, when talking about rectangular components, occasionally, yung motion daw ng particles can be described along a path that can be expressed in terms of x, y, z. Ibig sabihin, nasa 3D plane tayo. No? So, para daw distinguish natin yung position niya, pwede natin gamitin yung napag-aralan natin before, I think midterm or prelim pa, yung position vector natin. Wherein yung position vector natin is, yun yung vector from the origin papunta dun sa position ng mismong particle natin. Okay? And this particle, and this vector, or yung particle natin, when it moves, it will be yung change niya will be a function of time. So, at any instant, yung magnitude daw niya, pwede natin makalculate by getting the square root of the values of the x, y, z components. Okay? And yung direction daw natin will be identified using yung unit vector natin na r. So, basically, yung r niya dito is itong vector na to, and then itong um, R na nasa ilang natin is yung magnitude natin. Okay? So, yun yung para sa position. So, for the velocity, madali lang siya. Yung first time derivative siya, o sabihin, derivative with respect to time nung R function natin na na-calculate natin, yung R vector natin. So, kapag dinerive natin, again, yung position natin with respect to time, once, makukuha daw natin yung velocity vector natin. Okay? And si velocity vector, ayan, Vxi, Vyj, tsaka Vzk, wherein yung Vx, Vy, and Vz dito. So, ibig sabihin lang niya, yung position natin with respect to x, dinerive natin with respect to time, no? Tapos, yung isa is yung y natin, dinerive natin with time, and then yung z natin, dinerive natin with time. Okay? And then yung velocity magnitude, again, the same lang din. Once nakuha natin yung vector natin, kunin lang natin yung mga coefficients ng ijk component natin, then square natin h, then kunin natin yung sum ng square root, makukuha natin yung magnitude. And yung unit vector, yung para sa direction, are given as the vector divided by the magnitude. Okay? Then, as predicted, for acceleration, It's just the second derivative nung ating position vector, yung r natin. Or first derivative nung mismong velocity vector natin. So we have here, pag dinerive daw natin yung velocity vector natin, and dinerive din natin yung ating position vector twice, we will have our acceleration vector. So yung ax, ay, and az are just vx over dt, no? Or drx squared over dt squared. So yung second derivative, no? And then same na din, magnitude for the acceleration will be just the square root of each coefficient of those vector, and then kunin natin yung sum, and then yun, kunin natin square root para sa magnitude. And then for the direction, so formula tayo ng unit vector is equals to the acceleration vector divided by the magnitude. Okay? So apply natin sa example. So we have our first example. At any instant, the horizontal position of the weather balloon as shown is defined by x is equals to 80. Okay? Yun daw yung position, horizontal position natin na equation. Then where t is in seconds, if the equation of the path, so ito yung sinusundan mismo ng balloon natin. So ito yon. So makikita nyo, curve siyang ganun, and naka-x squared siya, so parabolic siya, no? Is given as y is equals to x squared over 10. Determine now the magnitude and direction of the velocity and the acceleration when t is equals to 2 seconds. So, basically, pinapahanap lang sa atin yung velocity and acceleration ng given function, given yung path natin, and then yung x value natin. Okay? So, to solve this, what we can do is find an equation kung ano yung pwede natin derive, no? And si y is yung ating position vector, no? Siya yung path nung mismong nung weather balloon natin. So ibig sabihin, dependent sa kanya yung position nung mismong balloon natin, no? So kung meron tayo nung equation natin na y is equals to x squared over 10, tingnan natin, meron din tayong equation para dun sa x. Meron tayong x is equals to 80. So, pwede natin i-substitute na yan, no? Is equals to 80. So, pag sinubstitute natin, this will be 80 squared over 10 is equals to y. So, y is equals to 6040 squared over 10 or equals sa 6.4t squared. So, meron ka ngayong formula for the position. Eh, di ba kailangan lang natin is yung velocity and acceleration. So, ang gagawin lang natin, i-derive na lang natin once itong nakuha natin equation na to for the velocity, and then derive natin twice para makuha natin yung acceleration. Okay? So, deriving this one, first derivative natin will be 6.4 times 2 times t, no? So, ano yung t natin? Given naman na t is 2 seconds. So, ibig sabihin, this will be 6.4 times 2 times 2. So, pag kinalculate natin, 6.4 times 2 times 2, that is 25.6. So, yung first derivative natin is velocity. So, ang unit natin will be, since feet tayo, so feet per second tayo. Okay? So, this will be our magnitude for the velocity. Okay? Pero ano yung velocity niyan? Since ang equation natin is y, no? Yan is vy tayo, no? Okay? And then yung sa x natin, x is equals to 80. Okay? Kunin natin yung first derivative para makuha natin yung velocity. So first derivative niya will be equals to 8. And ang first derivative natin equals sa vx natin. Okay? So ibig sabihin, vx natin is equals to 8 feet per second. Okay? So meron tayong value for vx and vy. Makukuha na natin si v natin. It's just the square root of vx squared plus vy squared. Okay? So substitute natin yung value. We have 8 squared plus 25.6 squared. Getting that value, so we will arrive with 26.821 feet per second. So this will be our magnitude, no, for our velocity. Okay? And then, next natin is yung direction niya. So, since two-dimensional lang tayo, x and y component lang tayo, uh, si velocity is acting tangential dun sa point kung nasan tayo, no? So, kung halimbawa, at 2 seconds yung pinag-uusapan natin, let's say, ito yung point na yun, no? Okay? Yung na-calculate talaga natin is yung velocity na yan. Tangential siya. Okay? And nalaman naman natin yung component niya. Ito yung x, ito yung y. So para makuha yung direction niya, Pythagorean lang tayo. Okay? So, di ba, ito yon yung v. Then ito yung vy natin, ito yung vx natin. So para makuha natin yung direction ng velocity natin, that will be, na tayong vy and vx, so tangent of theta will be equals to vy over vx, or theta is equals to shift tangent or arc tangent is equals to vy natin is calculated as 25.6 all over 8. So theta natin will be equals to 25.6 divide 8. That will be 72.646 degrees. So ito naman yung ating direction for the velocity. Okay? So okay na tayo dun sa velocity. Okay? Next natin is yung acceleration naman tayo. Okay? So, copy ko lang to. So, si acceleration kailangan natin. So, meron na tayo nakuha kaninang formula for yung first derivative natin ng y. Ang formula nakuha natin is yung 6.4 times 2, that is 12.8, no? 12.8t. Ito yung first derivative natin. And sa x prime, equals tayo sa 8, no? So for acceleration, kunin lang natin yung second derivative niya. So y double prime, 12.8. So ibig sabihin ito yung equal sa ay natin. And then ito, second derivative niya, since constant, that will be 0. Equals yun doon sa ax natin. Okay? Then, getting our magnitude is just ax squared plus ay squared. So, that will be 0 tas 12.8. So, pag plug in mo, lalabas lang ulit yun. 12.8 feet per second squared yung value ng ano natin. Okay? And then, para naman sa direction niya, so, tangent, theta is equals to ay over ax. So, theta is equals to yung ay natin is 12.8, then 0, tas tangent. So, since ito is nag-undefined, and para magkameron tayo ng value for tangent ng undefined, so, what we can do is, kunin yung value niya, no? So, since undefined yan, so, yung direction natin, since yung mismong ano naman natin is moving tayo, no? So it's either 0 o 90 lang pag nag-arc tangent tayo. So si 0 hindi pwede. So 90 degrees tayo. So ibig sabihin yung direction ng acceleration natin, kung ito yung balloon natin, okay? Yung acceleration natin is pataas na siya, no? Yung acceleration natin na 12.8. So ibig sabihin yan, ito yung theta natin. Okay? Kasi yung direction ng balloon natin is going up. Okay? Alright? So, this is our answer for number 1. Okay? Another example is given. So, for a short time, the path of the plane in the picture. So, we have here, ayan, yung picture natin. So, ayan yung plane. I don't know if you can see it, but ayan, yun yung plane. It's described by y is equals to 0.001. So, ibig sabihin, meron tayo dito parabolic function dito. Okay. So, yung formula niyan is y is equals to 0.001x squared. Okay. So, if the plane is rising with a constant velocity, so constant ang velocity, no? So, pag sinabing constant velocity and rising siya, no? So, ibig sabihin rising, so Vy is equals to 10 meter per second. No? Determine the magnitude of the velocity and acceleration of the plane when it is at y is equals to 100 meters. Okay? So, yun yung pinapahanap sa atin. So, to get yung ating value, no? Kailangan gamitin natin yung function natin. So, yung function natin is y is equals to 0.001 x squared. So, anong pwede natin gawin? So, gamit itong equation na to, pwede natin makuha yung value uh, nung value nung ano natin, nung velocity natin, no? So, kung matatandaan nyo sa calculus, parang tayo tatawag na implicit differentiation. So, dito, dalawa yung variable natin, si y at si x, no? Ay, di ba, with respect to time yung ating kinoconsider. So, dito, pag dinerive natin, so y prime, gawin ko na lang y uh, dot y, no? Meaning first derivative. And then ito, this will be 2x as yung derivative ng x. Okay? So, ibig sabihin yung first derivative ng y, that is equals to by. Then ito will be 002x. And then ito will be bx. Okay? Kasi first derivative ng x function niya. So, ibig sabihin velocity. Okay? And then, ayan. So, kailangan natin ng x value, no? Kasi wala tayong value ng x dito. Kung isa-substitute natin si 10, wala tayong value ng x. No? So, kung makukuha natin si x by substituting yung value natin na 100 dun sa equation natin. Okay? So, let's try dito. Gawin natin 100 is equals to 0.001 x squared. So, divide natin by 0.001, 0.001. Okay? Then, square root natin both sides. So, x will be equals to 100 divide 0.001, that's 100,000. The square root of that value is 316.228 meters. No? So, ito yung x value natin. So, meron na tayong pwedeng substitute ngayon dun sa na-derive natin equation. So, this will be 10 is equals to 0.002 and then 316.228 then Vx. So, makukuha natin ngayon yung value ng Vx. Okay? Then, divide 0.002 times 316.228. That is 15.811. Okay? Ito ay meter per second. Since velocity tayo. So, meron na tayong value ng Vx, meron na tayong value ng Vy. So, substitute lang natin. And that will be V is equals to square root of 15.811 squared plus 10 squared natin. So, value of velocity natin is 15.811 squared plus 10 squared. That will be 18.708 okay, meter per second. So, magnitude of the velocity. So, ito yung magnitude ng velocity natin. Okay? Then next, para makuha natin yung ating acceleration, gagamitin lang natin again yung formula ng velocity natin. So, meron tayo kaninang Vy is equals to 0.002x Vx. No? Pag dinerive natin to, this will be Vy dot is equals to, so, ito will be derivative siya ng product, no? Derivative nitong dalawang to. So, derivative ng product. So, balikan nyo yun. So, 0.002x times yung first derivative ng Vx and then plus 0.002 Vx and then yung derivative ng x is x dot, no? So, substitute natin. Yung Vy dot natin, that is equals to Ay. Okay? And to 0.002 x, yung Vx dot natin is Ax. plus 0.002 Vx, and yung x dot natin ay velocity, first velocity. So, ito magiging squared na to dito. Okay? Next. Hindi natin yung equation natin na y is equal to 0.00. Sige. Hindi na pala to. Next, meron tayong value for we have velocity. So, kailangan natin ng value ng ay at ax, no? Kailangan hanapin natin yung value niya. And, paano natin malalaman ngayon? So, see, okay. So, si ax is unknown, no? Unknown to si ax. Si x is identified natin as 316. Okay? Si bx, calculated natin siya as 15.811. So, si ay, okay? Okay. So, dito, si by natin kanina, dito, is 10, no? Pag dinerive natin si vy, that will be our acceleration in y. Pero derivative ng constant ay equals sa 0. So this will be 0. So equals to 0.002. X natin is 316.228. AX plus 0.002. VX natin is yung unknown natin. And then, AX nga pala. So VX natin is 15.811 squared. Okay? So solving, AX natin, ang value niya will be equals to, so 0.002 was 15.811 squared divided by 0.002 times 316.228. Our answer is 0.791 feet per second, meter per second squared. Dapat negative, no? Kasi nag-transpose tayo. Second squared. So, pinapanap sa atin is accelerate magnitude. So, that will be negative 0.791 squared plus 0 squared. So, A natin will just be equals to meter per second squared. So, this will be our answer for our acceleration. Okay? So, ganyan gamitin yung para sa rectangular component nung velocity and acceleration natin. Okay? Next, we now go to some motion of a projectile natin. So for this type of problem, what I would suggest para mas madali natin maintindihan siya is to just focus on this following formulas, no? So for horizontal motion, equation natin is yung ito lang, x is equals to x sub 0 plus v sub 0 t, which is just based from our constant acceleration formula, no? Okay? Kahit yung sa vertical motion equation. Pero yun yung mga kailangan tandaan nyo na lang na formulas. Okay? So discuss lang natin yung mga subscript. So si x defines yung location natin ng point. So limbawa, ito yung pinaka-extent yung location ng nag-throw tayo ng ball from point O. Tapos may projectile siya, path, na dito yung ending point niya. So yung x natin is yung final position natin. So x sub 0 is yung initial position. V sub 0 here is yung pertaining dun sa x to, no? Sa x to, hindi ko nalagyan ng x. So dapat ito ay yung x component ng initial velocity natin, which is constant along dun sa curve natin. So ibig sabihin, kahit nandito tayo, yung horizontal component ni initial velocity is always constant. Yan, lagay ko dito, no? And then times time. And then for the vertical motion equations, same lang din, position. Ito yung velocity ni y do sa hinahanap natin point. initial. Then acceleration natin. So acceleration, yung value lang natin is just syempre, acceleration constant natin is always 9.81 for English. And then pag pag SI 9.81, pag English 32.2 feet per second squared. Okay? So, ayan. So, ayan, tandaan lang natin 'tong mga formulas na 'to. Okay? So, let's apply sa problem para mas madali siyang ma-absorb, no? So, let's have this problem. A sack slides off the ramp with a horizontal velocity of 12 meters per second. So, given na ano siyang horizontal velocity. So, ibig sabihin ito ay v sub x na agad, no? If the height of the ramp is 6 meters from the floor, determine the time needed for the sack to strike the floor and the range r where the sack begins to pile up. Okay? So for this type of problem, what I would suggest is magkameron kayo ng reference axis, no? Para doon sa pag-identify nung positive, negative locations ng mga point natin. And I would suggest dun kayo kung saan nanggagaling yung mismong object, yun yung gawin yung reference axis. So, ibig sabihin, itong point A, kung nandito, ito yung consider natin na 0, 0, yung origin natin. Okay? So, ang location na kailangan natin is dito kay B. Okay? So, kailangan sa pagsasolve ng sa paglalagay ng given, kunin mo yung mga values niya sa horizontal direction and vertical direction. Okay? Isa-isayin natin. For the horizontal direction, okay? So yung XA natin, so ibig sabihin, yung position natin ng X at A is, since nandito sa origin, 0 siya. No? Okay? Position at B, kung saan yung file natin, yung consider natin, is, anong position tayo? So unknown sa atin, so uh, R yung nakalagay sa problem, no? Or just XB lang din, no? And then, ano pang pwede natin ilagay? Yung velocity natin, no? Which is given as 12 meter per second. And then, let's go dun sa ating vertical given. Okay? So, yung Y sub A natin. So, since ito yung, ano natin, so, Y sub A natin, location natin sa Y sub A is 0 pa din. Then, si Y sub B, ngayon yung magbabago, no? Since ito yung reference axis natin, si B is below dun sa ating horizontal line. So, ibig sabihin, ang position ni B is negative 6. No? So, dito, lagay mo negative 6 meters. And then, yung Vy natin is walang binanggit, no? Assuming siguro 0 na siya. Okay? Or, pwede, sa projectile, di ba? Ito yung initial velocity natin. Ito yung Vx component niya. Ito yung Vy. So, kung ito yung theta natin, si Vy is yung ating B sin theta, no? So, lagyan natin B sin theta. And then, ano pang given? Acceleration natin, which is always downward or papunta sa Earth, no? 9.81 meter per second squared. Okay? And then, ano pa? So, may given ko ba? So, dito, I think Vy is 0, no? Time is unknown. So, I guess we can start now with the solution, no? So, going back to sa mga equations natin, tingnan natin yung sa horizontal. X is equals to x sub 0 plus v sub 0 x times t. Okay? So, yung x na kailangan natin is yung position ni B, no? Is equals to x sub 0 natin is 0 plus 12 and then ito is t. Okay? Kung sabihin yung r natin will be equals to 12t. So, gawin muna natin to as first equation. Okay? Next equation natin, gamitin natin siguro is ito, wala tayong Vy. So, I think hindi natin masyado magagamit. O, try natin tong second sa vertical, no? So we have y is equals to y naught plus v sub yt plus 0.5 at squared. Okay? So, ang kailangan natin is yb is equals to y sub 0 natin is 0. Y sub 0 y natin is 0. T plus 0.5 negative 9.81. Then T natin is unknown. Okay? And si YB natin, alam natin si YB nandito, no? Negative 6 yung nakalagay sa atin. So, negative 6 is equals to 0.5 times 9.81. That is negative 4.905 T squared. Solving, we will have a value for T. Magiging positive siya, no? So, that is 1.106 seconds. Okay? So, kailangan ba natin yon? Determine the time. So, this is our answer for the time para makalapag siya doon, no? And then, para makuha natin yung range natin, substitute na lang natin dito sa equation 1 natin, yung time na na-calculate natin. Okay? So, R natin will be times 12 lang, no? So, that is 13.272 meters. So, that is our solution for this problem. Okay? Next. Okay. So we have a chipping machine is designed to eject wood chips at initial velocity of 25 feet per second. If the tube is oriented 30 degrees from the horizontal, determine how high the chips strike the pile if at this instant they land on the 20 feet pile. Okay. So again, consider natin na ito yung location ng ating origin. Okay. So pag kinuha natin yung mga location ulit natin, laging ganun yung simula, no? So, x sub a natin is 0. X sub, anong kailangan natin point? Itong point na to, di ba? Okay. So, iba ang pangalan niya dito, no? So, x sub 0 natin ay 0. Ang kailangan natin si a. X sub a natin is, alam natin, no, nakalagay 20 feet. Okay. And then si vx natin is, since meron tayong given na theta, and then, di ba, ganito nga lang yan. Ito yung Vy natin, Vx natin, theta, and then V. So, Vx natin is just yung value ng V natin, cosine theta, and then ang Vy natin is V sine theta. Okay? So, Vx natin is, value ng V is 25 cosine of 30. Okay? So, i-value na agad tayo niyan. Calculate lang natin. Cosine of 30. That is 21.651 meter per second. Okay? And then, yung sa vertical natin, lagay na din natin, no? So, y sub 0 natin is 0. Then, y sub a natin. So, kailangan natin si a. Yung h talaga yung nahanap natin. Pero, pag titignan natin yung figure natin, no? Ayan. Ano yung magiging distance nito mula dun sa x-axis natin? So, di ba kung 4 to, then may h ka dito. So, ibig sabihin ito will be 4 minus h. Okay? So, since below yan, minus 4 minus h. So, this will be negative 4 plus h. Okay? Then, Vy natin is given as yung V sine 30. So, that is just half nun, 12.5. Okay? And then, anong pinapahanap ngayon? Pinapahanap is how high yung h natin. And then, how high lang, no? So, yan. Try natin yung mga formulas natin again. Nahin natin sa horizontal. X, A is equals to X sub 0 plus V sub 0 X, T, A. So, yung time na makakarating siya dun sa point A. So, XA natin, solve na lang natin yung mga na-identify natin. That will be 20 is equals to 0 plus 21.651 TA. So, direct division na lang to. 20 divide 21.651 That is our TA. So 0.924 seconds. Okay? So may nakuha tayong time to reach A. And then para dun kay next formula, kay for vertical direction, um, anong pwede natin gamitin? So let's try yung sa y ulit. No? So y, A is equals to y sub 0 plus b sub 0 y TA plus 0.5 negative yung g natin TA squared. Okay? So YA natin is negative 4 plus h is equals to 0 plus 12.5 times yung TA natin na 9.924 plus 0.5 plus negative 9.81. Tama ba? Feet per second tayo. So negative 32.2 dapat. Times yung TA ulit natin na 0.924 squared. So pag natin, makikita natin pag simplify natin to, si h na lang yung unknown, no? So makukuha natin value ni h will be equals to 1.809 feet. Okay? So this will be our answer for this problem. Okay? So baguhin ko lang yung unit nito. So this should be feet per second pala tayo. Okay? So that is for number 2. And then think another last one na example. Okay? So the track for this racing event was designed so that riders jump off the slope at 30 degrees from a height of 1 meter. So during a race, it was observed that the rider remained in mid-air for 1.5 seconds. Determine the speed at which he was traveling off the ramp, the horizontal distance he travels before striking the ground, and the maximum height he attains. No? So neglect the size of the bike and the rider. Okay? So as usual, ito yung ating reference axis. Okay? So identify lang ulit natin yung horizontal natin. So x sub a natin will be 0. X sub b natin, kailangan ba natin x sub b? Yes. So r. No? Then later on, pinapatanong yung yung height, no? So balikan natin yan. So Vx, meron ba tayong Vx? May initial velocity ba tayong given? So walang initial velocity na given, no? Okay, so V lang tayo. So Vx natin will be equals to V cosine 30. Okay? So yaman na natin unknown siya. Okay? So sa vertical naman natin, yung YA natin, of course, is 0. Then YB natin is, since below yan, no? Below na yan ng axis natin, and ang distance niya mula doon is 1 meter. So, negative 1 meter na si B. Okay? So pa, si YC, no? Kasi, kailangan natin mamaya yan, no? So, pag si C naman pinag-uusapan natin, ano tong distance na to? Mula doon sa axis natin. So, kung H to, plus 1 to, so H minus 1, so matitira dito H minus 1. Okay? So, ito will be H minus 1. Okay? Pero, nasa taas siya ng axis, kaya positive pa din yan. Okay? Then, Vy natin is the same na V sine 30. And then, time na given sa atin is 1.5 second, no? So, yun yung time na nandun siya, nakalutang siya sa air. Kaya sabi mid-air. Okay? So, ngayon, pwede tayo mag-calculate, no? So, anong formula yung pwede natin gamitin? So, let's try yung first natin ulit sa horizontal, no? We have x. Try natin yung sa B muna, no? position natin sa B. Okay? Is equals to x sub 0 plus v sub o x t b. Okay? X sub b natin is r. Okay? So x sub 0 o yung xa natin will be 0. Bx natin plus b cosine 30 times 1.5. Okay? So yung r natin is may value siya sa 1.299 b. Okay? Equation 1 natin yan. Next equation natin is yung y sub b equals to y sub 0. Initial natin, y sub a plus v sub 0 yt plus 1 half gt b squared. Okay? So yb natin is negative 1. Ya natin is 0. Plus voy natin, b sine 30 times 1.5 plus 1 half. And then this is metric tayo. So negative 9.81 times 1.5 squared. So unknown na lang natin ay si v. No? So may makukuha tayong value ng velocity. So pag kinalculate natin, negative 1 minus 0.5 minus 9.81, 0.5 squared divided by sine 30 times 1.5. That is 13.382 meter per second. So may nakuha tayong value ni V. Makakalculate na natin yung range natin. No? 1.299 times 13.382. So that is equals to 17.383 meters. No? So may velocity na tayo. Ano pa ang pwedeng hanapin natin? So yung h na tayo, no? So meron tayong isang formula na ang given is yung velocity natin at point C, yung y squared is equals to yung initial natin, no? Boy squared plus 2a tapos yung y sub c minus y sub 0 natin. So ito yung I think yung nandito sa pang ilang equation ba yon? So ito, no? Ito 'yan. Okay? So substitute natin. So since yung point C natin dito sa figure natin is yung highest point natin. Alam natin na kapag na-reach na ng object, sabi natin sa free folly bodies, kapag na-reach na ng object yung highest point niya, ang velocity niya doon is magiging 0 na, no? Kasi ano na kumbaga naubos na yung puwersa niya, kaya tendency niya bumaba na. So kaya ito will be 0 is equals to yung BOY natin is 13.382 sine 30, no? Plus 2 times negative 9.81. And then yung value ng YC natin is, again, H minus 1 tayo, minus 0. No? So wala naman yon. And then kapag to, sinimplify natin, ang makukuha nating value, we will have 3.28 meters as our value for H. So ito yung hinahanap natin for the maximum height na kaya niyang i-attain, no, mula doon sa ground natin. And then, ano pa, yung speed, no? Speed natin is ito. And then, horizontal distance natin is ito. Okay? So, na-solve na natin yung unknown dun sa problem. Okay? So, yan para dun sa projectile motion. Okay? So, yung last topic natin is for normal and tangential component ng acceleration natin. So, for this particular problem, or ganitong problem, may bagong equations tayo na dadagdag dun sa mga napag-aralan natin from part 1 hanggang sa point na to, no? So we will be introducing 3 more equations. Pero hindi na naman bago yung dalawa, no? Yung isa lang bago. Na yung sa normal acceleration daw natin, yung natawag natin a sub n equals daw yan sa b squared over rho. So ano yung b squared natin? Si b dito is yung velocity natin and then ito is yung ating radius of curvature, no? So dapat tandaan sa radius sa theory, no? Napag-usapan na yan sa theory. Si radius of curvature sa strength of materials, sa pag-usapan na din yan. So yan yung radius of curvature natin. So halimbawa um, may parang imaginary circle dito. Then ito yan. Okay? So dito. So ganyan yan. Okay? So ito yung unang equation. AN is equals to V squared over rho. And then we have yung formula for radius of curvature. Pag hindi given yung radius, pwede natin siya makalculate by getting the first derivative and then second derivative ng function and then substituting it ito sa formula na to, which is given as 1 plus squared ng first derivative, all of its raised by 1.5 divided by the absolute value of the second derivative of the function. Okay, so yun yung row natin. And then for the magnitude of the acceleration, since hanapin nga natin yung magnitude ulit, si AN squared plus AT squared. So si AT squared, siya yung nakakalculate natin dun sa problem natin. So ano pala siya, transverse tangential acceleration pala yung nakakalculate natin or yung mga naka-tangential, no? Makikita nyo dito sa figure, no? Ayan. Yung mga nakakalculate natin since 'di ba yung velocity natin nakatangent din siya dun sa particle natin. Same with our acceleration kapag meron na ng change in velocity, no? Tangential din siya. Tapos si AN naman is laging acting towards dun sa ating radius of curvature, no? Lagi siyang naka-normal dun sa point natin. And then yung kanyang hypotenuse or yung kanyang resultant ng dalawang yon is our magnitude ng acceleration, which is yung kailangan natin hanapin for our problem dito sa mga gantong cases. Okay? So, apply natin sa example. So, application number 1. So, when the skier reaches point A, okay, so ito may nag-i-ski. So, ito is mountain slope siguro na snow, no? Along a parabolic path. So, may parabolic dito sa certain portion na to. Ayan, ito yung parabolic. Okay? May speed daw siya at that instant na 6 meter per second, which is increasing at 2 meters per second squared. Okay? Determine the direction of his velocity and the direction and magnitude of his acceleration at this instant and neglect the size of the skier in the calculation. Okay? So, ano ba yung mga given natin? So, meron tayo, ayan, so nakalagay yung VA natin at that point is 6 meter per second. Okay? Then may given siya na increasing at yung acceleration daw is increasing. So, at that point, meron din tayong tangential acceleration na 2 meter per second squared. Okay? So, ngayon, given sa atin yung path. Okay? So, may given sa ating function. Okay? Ito. So, y equals to 1 over 20x squared. Okay? So, alam natin na pag kinuha natin yung first derivative niyan, ano makuha natin? Yung velocity y natin. Okay? So, y dot natin will be equals to 1 over 20 times 2 x, no? Okay? Ano tong nakuha natin to? With respect to x to, no? So, wag nating i-change siya. So, gawin natin tong dy over dx. Okay? Para hindi natin kukunin dito um, yung bx, no? So, ano ba tong dy over dx natin? Ano bang yung nahanap sa atin? Yung direction ng velocity natin. Okay? Direction ng velocity. And si direction, kapag ganyan, is kailangan natin kunin. So, kung ito yung point ng si skier, no? And then, ito yung velocity A natin. Okay? So, ito yung x-axis natin. So, pag pinapakuha si direction, kailangan natin is itong theta na to. Okay? Which is also equal dito sa theta na to. And kapag meron tayong curve and nagtangent tayo ng line, para makuha natin si theta, according to differential calculus, si theta natin can be equals dun sa tangent nung m natin, yung slope natin. Okay? And si slope equals yan sa dy over dx. Kaya itong nandito, kinukuha natin si dy dx. So equals to sa 1 over 10 x. And anong value ni x? So at that point, ang value ni x natin is 10 meters. No? So 10 over 10 is equals to 1. So ibig sabihin, para makuha natin si theta ni v, that will be tangent, negative 1, 1. So theta natin is 45 degrees. Okay? So that will be our answer for the velocity direction. Okay? So ito yung direction ni velocity. Okay? Next. Paano natin makakalculate? Kailangan natin si acceleration, magnitude ni acceleration and direction ni acceleration. So kailangan natin ng value ng AN tsaka AT. And na ano natin na ang value ni AT is already given as 2 meter per second squared. So, kailangan natin kunin yung AN natin. And again, si AN, ang formula niya is B squared over radius of curvature, which is not given. So, kailangan natin i-calculate si radius of curvature. So, ito is dy over dx. So, dy over dx squared, 3.5, 3 halves or 1.5 over second derivative d squared y over dx squared, absolute value. Okay? So, meron na tayo nakuha kanina na dy dx, no? Na equals sa 1 over 10x. Okay? So, kunin natin yung second derivative niya with respect to x. That will be 110. So, substitute lang natin. That will be 1 plus dy over dx um, is 1 over 10 x. So, pero since doon din tayo same point din, 10 din yan, squared, 1.5 divided by, so 1 over 10. Okay? So, pag kinalculate natin, rho will be equals to 28.284. Okay? Meters. Okay? So, para makalculate natin ngayon um, si AN, so AN now will be equals to B squared natin is 6 squared over 28.284. So, on calculating, that is 1.273 meter per second squared. Okay? AN natin yan. Tapos kailangan natin ng 80. So, given na si 80. So 80 natin is 2 meter per second squared. Again, AN calculated is 1.273. Makakalculate na natin si A using AN squared plus AT squared. So A is equals to 1.273 squared plus 2 squared. So A natin will be equals to 2 squared. So that will be 2.371 meter per second squared. Okay? So that is our acceleration. And then kailangan natin ng direction din. So paano naman yung si acceleration? Okay? So same din, ito yung point natin. And then ito yung tangential acceleration natin. Okay? Then ito yung level ground natin na parallel kay X. Okay? And then ano ba? So meron tayo dito. Ito yung ating AN, no? Ito na-calculate natin siya as theta kanina. Then ito since perpendicular, 90 degrees yan. Then assume natin ito yung location ng A natin. Okay? So kailangan natin move natin. Ayan. So kailangan natin yung position ni A, no? So ito tawagin nating alpha. Okay? So paano natin makukuha si alpha? Pag pinroject natin si ito. So si alpha makukuha siya by taking tong angle na to. Tawagin natin beta. Okay? So ito si 80 natin, ito si AN. So beta, so opposite, adjacent, so tangent, beta is equals to 80 over AN. So beta natin is equals to arctangent times 80 natin is 2 over 1.273. Beta is equals to 2 over 1.273. That is equals to 57.523 degrees, no? So, ngayon, makukuha natin si alpha. So, kung based dito sa figure natin, so mula dito hanggang dito, ilan yan? So, that will be 180 plus alpha is equals to, hindi. So, yung theta plus 90 degrees plus beta, okay, ay equal sa 180 degrees plus alpha. Okay? Substitute natin. Calculate natin kanina kay 45, 90, 57.523 is equals to 180 plus alpha. So, alpha natin will be equals to 45 plus 90 plus 57.523 minus 180. So, alpha natin is 12.523 degrees. So, this will be our direction for our acceleration na to. Okay? So, matter of geometry na lang din, ano? Kung paano natin na-calculate yung degrees natin for that. Okay? And then we have, I think this is second to the last one. Okay? So, a race car C travels around a horizontal circular track that has a radius of 300 feet. If the car increases its speed at a constant rate of 7 feet per second squared, starting from rest, determine the time needed for it to reach an acceleration of 8 feet per second squared. What is the speed at this instant? Okay, so may given tayong radius. So, automatic, no? So, radius natin, yung radius of curvature natin is 300 feet. Okay? And then, if the car increases the speed at a constant rate of 7 feet per second squared, so sa 7 feet per second squared ay uh, tangential natin, no? Okay? Then starting from this, so ibig sabihin ang initial velocity natin ay 0. Na-determine the time needed for it to reach an acceleration of 8 feet per second squared. So yung A na hinahanap natin na magnitude na given is 8 feet per second squared. What is the speed at this instant? Okay? So, maximize muna natin yung given. So, meron tayong constant rate ng acceleration. So, kung may constant acceleration tayo, pwede natin gamitin yung formula natin again na V is equals to V sub 0 plus AT. No? And then, hindi natin alam yung V. Si V sub 0 is 0 plus ang acceleration natin, tangential is 7. So, T. So, meron tayong formula na 7T yung velocity hinahanap natin. Okay? And then, kunin natin si AN. Ang AN natin is V squared over rho. V squared natin, calculate natin, 7T squared over rho natin na 300. So, this will be 49 T squared over 300. Okay? And then, given sa atin si A, so A is equals to square root of AN squared plus AT squared. So this can be also A squared is equals to AN squared plus AT squared. Okay? So si A natin is 8 squared. AN natin is 49T squared over 300. And then dapat naka-squared pa yan. Plus 80 natin. So 80 natin is 7 squared. Okay? So solving for T, may makukuha tayong value, no, na 4.870 seconds. Okay? Kung meron tayong value ng T, substitute natin sa V. So 70. So 7 times 4.870. So velocity natin is 34.09 feet per second. So determine the time needed. So ito yung time needed na pinapakalculate. And then yung ating speed at that instant is this one. Okay? So, using yung concept din ng constant acceleration formula and then applying lang yung normal and tangential acceleration natin to get the value for the velocity. Okay? Then last, we have here, a truck travels in a circular path having a radius of 50 meters at a speed of v is equals to 4 meters per second for short distance. From s is equals to 0. Its speed is increased by v dot is equals to 0.05 s meter per second squared, where s is in meters. Determine the speed and the magnitude of its acceleration when it has moved s is equals to 10 meters. Okay. So may given tayong ito yung mga given natin. Ano? We have a radius, may rho tayo na 50 meters. And then we have a speed na 4 meters per second. Yun yung initial velocity natin. For short distance from 0, and its speed is increased by yung acceleration formula natin in terms of s is 0.5 s. Yung formula natin. Determine the speed and the magnitude. S is equals to 10 meters. Okay? So what we can do, I think, is to maximize yung yung formula pag may variation acceleration tayo. Tatandaan niyo yung VdV is equals to AdS. No? So pwede natin gamitin to. No? Again, galing yan dun sa formula na ang V is equals to ds over dt and si A is equals to dV over dt. So Pinag-equate lang to, ds over dt, ds over v, sorry. Then ito is dt is equals to dv over dt. So magiging ds over v is equals to dv over dt. Excuse me. S, saan is S? This will be dt dv over a, sorry. A, and then pag natin, ADS is equals to PDV. So ito yun. Okay? And then, um, yung V natin, VDV natin, ang initial natin is 4. Hindi natin alam yung final velocity niya. Then acceleration natin, in terms ng S naman yung formula natin. So we have 0.05 s ds. Limit natin is from 0. Then yung inahat natin is from 10. Okay? So applying integral lang. So this will be V squared over 2. So this is V4 is equals to, this will be 0.05 s squared over 2 and then 10, 0. Okay. Simplifying this one, we have V squared over 2 minus 16 over 2 is equals to 0.025 times 10 squared. Okay. Then to, pag to sinimplify na to, yung V natin, makakalculate will be 4.583 meter per second. So, ito yung velocity natin at that at 10 meters, no? And then kailangan natin is yung acceleration, magnitude ng acceleration, and given sa atin yung 0.05 s, no? Pag sinubstitute natin yung 10, yan yung ating tangential, no? 0.5 meter per second. So wala tayo nung normal, which is v squared over rho, that is 4.583 squared. Divide natin dun sa rho natin na 50. Okay. An natin will be equals to 0.42 meter per second squared. So acceleration natin, square root lang ng tangential and normal squared plus 0.5 squared. A natin will be equals to 0.653 meter per second squared. And this will be our answer for this problem. Okay? So basically, tandaan lang natin yung additional 3 formulas para i-apply natin yung concept nung mismong natin. Yung sa natin. DV natin. Okay? Okay, so this ends our lecture for today. And I hope madami kayong natutunan dun sa Curvilinear. And I'll see you guys again on the next session. Thank you.